Hello, ladies, gentlemen, and in between, and welcome back to another episode of Maths with Hamblin with your beautiful host, Hamblin. And today we're going to be applying our skills we learned last video with solving cubics and learning how to graph the xy graphs of cubic functions in preparation to learn how to solve cubic inequalities. It's going to be a wild ride. Let's go. Okay, so the first part of learning how to graph cubic functions is learning the general shape of a cubic equation. Now, in general, they all have this lovely little shape here where they come down from either the top or bottom here. They swoop up and then they make this nice little hump. They have two little minimum maximums here, like a nice little valley and a peak here. So that's the general shape of a cubic, but it can vary, as you can see on these graphs here. Now, the first case for what your cubic function may look like is when you have a positive coefficient in front of your cubic term. The reason I put a dot 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 here is it doesn't matter for the rest of your cubic. It entirely is determined by the sign of the coefficient of your x cubed term. If it's positive, then it comes from the bottom left here, it swoops all the way up, and then it does a little turn around and then swoops back up to the top right. That's the case for the positive coefficient. Now, if your cubic function has a negative coefficient in front of your x cubed term, then you end up coming instead from the top left, swooping down, then going back up again, and then going from the bottom right. It's very important that you memorize, you're going to have to memorize these, I'm afraid, the general shapes of these cubic equations, that they come up from either the top or the bottom, they swoop up or down, and they do this nice little curvy action there. And remembering that if you have a positive coefficient, it comes from the bottom left, top right, and if you have a negative coefficient, it comes from the top left and then swoops down to the bottom right. So now that we know the general shape of a cubic graph, I'll keep that on there so you can get a good look. We shall go into our first actual thing. Let's do it. Okay, right, so let's try and graph our first cubic function. Now, this is the lovely cubic function we're going to graph here, and you can tell it's a cubic function because it's the product of three linear factors. Linear meaning you've only got x to the first power here, because if you expand it out, then you just get a cubic as you get an x cubed as your highest power of x, so it's a cubic polynomial. Anyway, so how we go about graphing, or any function really, is there's a few key things on the graph that you have to remember. So if we're going to graph this, I'm going to set up a nice little x and y plane here. Now, just as is with quadratic graphs, we're going to need some key points we're going to have to plot in order to make it a nice graph so that we can actually use it, use it to solve inequalities, which is what we're actually going to use them for. And those key points are where they cross the axes. For example, if you had a cubic that came like whoop here, where it crossed right there, where it crossed the x-axis, is a point we'd have to mark so we can use it for what we want to use it for. So we need to figure out the points where it crosses the x-axis and the points where it crosses the y-axis. Now, the points where it crosses the y-axis, that's actually quite easy. That's just the point here. At this origin point here, that's where x equals 0. So if we want to find the y-intercept, all we have to do is plug in f of 0, see what we spit out, and then we can just plot that, and then we get the y-intercept. I hope you can see that. But the x-intercept, that's slightly more difficult. Say again, if it intercepted at this point here, then we're going to have to be a bit more clever about this. At this x value here, the y value equals 0, right? That's the definition of an intersection at the x-axis. It's where the y value equals 0, but it hits the x-axis. So at this x value here, what's actually happening is when you plug it into this function, it outputs 0 because there's 0 y-coordinate. So if we want to figure out what this x-coordinate is, we're going to have to solve the equation f of x equals 0 so we can figure out the x-coordinate. So we have to basically set this equal to 0 and solve for the x values. Now, but we learned how to do this last episode, and there's a reason I've started off with three factors here. It's because it's quite easy. Now, if we want to solve this equals 0, I'll just write this down here. Right, now, let's try and solve this when it equals 0. Now, this is pretty easy. We can just do the usual business when we've got some kind of product of factors, right? We've got a multiplication of a few things, it equals 0, so one or more of these has to equal 0. So if we go case by case, for this thing to equal 0, we need x to be equal to 1/2. In the case where this equals 0, x will be -4, and for this one, x is 3. So boom, there, easy. We've solved for all the roots of our cubic polynomial, and therefore we've solved for all the x-coordinates of the points where the curve will intersect the x-axis. So we can plot that on our diagram. It will intersect at 3. I'll call this one -4 and at 1/2. Okie dokie, right, but how do we know which cubic we're dealing with? Because couldn't it be uppy downy or downy uppy, right? Well, so we need to deduce what that is. We need to figure out the coefficient of x cubed, whether it's positive or negative. And we can actually do that just by looking at the factorization. Right, so if we think about what will happen when we expand this cubic, when we actually get to the x cubed term, we're going to need to do 2x times x times x, right? There's no other way to get an x cubed term by multiplying this out, right? And if we do 2x times 1x times 1x, we're going to get positive 2x cubed. We're not going to get a negative. So we can actually deduce that this is going to look like this. Okay, and now we can just, oh wait, actually, we've got to do the y-intercept. Thanks for reminding me. Anyway, so to get the y-intercept, we just need to plug in x equals 0 and see what value the function spits out so we can plot it, right? If we plug in f of 0, we can just put all the zeros where we see x's. This will be 0, so we're going to get a negative 1 times 4 times negative 3. That's going to be positive 12 because the negatives cancel. So we're going to get a positive 12, which I'll just mark up here. And there, we've got all the information we need to graph our cubic. So it starts from the bottom because it's a positive, and it comes up, swoops, crosses the y-axis, swoops down, and then comes back up. That is horrendous. A horrendous drawing, but it's the general idea. It comes from, swoops, and then goes back up, crossing all our points. Well, you know, kind of crossing, but you know, crossing all the points we plotted. So boom, there. As a recap, to find the y-intercept, all we needed to do was plug in x equals 0, see what it outputs, and then plot that. And then to find the x-intercept, well, that's when the function is outputting a value of 0, because there's 0 y-coordinate. So we just need to solve the equation, f of x equals 0, which is what we did here. Absolutely splendid. Now let's try that with a bit of a harder example. Okay, so let's try that technique on a slightly harder example here. Let's look at our cubic function here. F of x equals x minus 7 in brackets multiplied by 6 minus 4x minus 2x squared. And you can tell this is a cubic because if you expand this all out, the highest power term you'll get is an x cubed. So yes, this is indeed a cubic, so we know what the general shape will be. Now, next thing we need to deduce, what kind of cubic will it be? Will it be a positive coefficient cubic or a negative coefficient cubic? Now, that's kind of a daunting task, right? We don't really want to expand it all out, and that's going to be a lot of work. There's a trick to do. We can just look at the factorization and instantly know what kind of shape it will be, just like we did last time. So let's use our brains here. The only way we can get an x cubed term when we expand this, the only time we will get an x cubed, is if we do x times negative 2x squared. Now, if we do x times negative 2x squared, we're going to get to negative 2x cubed. So the coefficient of x cubed in the expansion will be negative 2. So this is a negative coefficient cubic. So we know it's going to start here and go, whoa! Okay, that's brilliant. Now, the next thing we need to do is identify the points where it intersects the axes, where the curve will intersect the axes. Let's start with the easy one, which is the y-intercept. The point where it intercepts the y-intercept will be where x equals 0. It will be the output of the function where x equals 0. So all we need to do is plug in x equals 0 and see what pops out, and then we can plug that. Then we can, plot that. So if we plug in x equals 0, we're going to get, well, minus 7 times, these two terms will get murdered. We're going to get minus 7 times 6, which is, God, minus 42. So I'm going to plot that right down there. Absolutely fantastic, minus 42. Sorry if you can't see that. I'll make that actually a bit bigger for you guys. There. Absolutely fantastic. Right. Now, the next part. To find the x-intercepts, we're going to have to solve the equation f of x equals 0. Now, if we do that, we're going to get product of two factors equals 0, and we're going to have to go factor by factor. So this first factor is pretty easy. To make that equal 0, all we need is x equals 7. Boom, first solution of our cubic. Sorry, that's terrible, 7. X equals 7 is our first solution. Now, to get the other two solutions, we're going to have to solve this quadratic factor when it equals 0. And oof, it's got a negative coefficient. I'm just going to use the quadratic formula, guys. I hope you're okay with that. And if you're not okay with that, watch my video deriving it. Anyway, so using the quadratic formula, our values for x are x equals negative b, which in this case is 4, plus or minus square root. Okay, negative 4 squared, 16. Then we're going to get minus 4 times a, which is minus 2, times c, which is 6. Smashing. And then over 2a, which is negative 4. Okay, now let's do some simplification. Minus, minus, positive. 4 times 2 times 6, that's 8 times 6, which is 48. 16 plus 48 is 64. Square root 64, I just dropped my pen out of excitement, that's 8. Cool. Right, so we can rub that whole expression out because that simplifies to 8. And we get 4 plus minus 8 over minus 4. Okay, so now let's just take the positive branch and the negative branch separately. 4 plus 8 is 12, divided by negative 4 is negative 3. So our first solution is, well, our second solution actually is x equals negative 3. And then taking the negative branch, 4 minus 8 is minus 4, and then minus 4 divided by minus 4 is positive 1. Nice, right, so get rid of that. And these are at our final root. Okay, so this is fantastic. We've got the y plot, we've got all 3 roots of our cubic, and so we can plot the cubic nicely. Right, so x equals 7 is our first x-intercept, x equals 1, x equals minus 3. Okay, now we just need to draw the general shape of the negative coefficient cubic graph. So it's going to start from here, swoop down, go up like that, scatar, epic. Right, so it's going to come down from here. I'm going to touch that, go back up, and then swoop back down. And then boom, we've successfully graphed our cubic function.